All right, we're going to jump into this review video, which is going to be on chapter 15 and 16. So we're going to go over some logarithm review here. And we'll start with the basics, which was just to rewrite these logarithmic equations into exponential form. And so remember, to do that, we were just kind of going through this pattern here, okay, where the base of the the base of the log becomes the base of the exponent. So this become 2 to the 5th power. And that's always going to equal whatever the big number is there, in this case 32. All right, they're just asking you to rewrite it, so that's all you have to do for that first one. Same process here, a base of the log becomes the base of the exponent, so 11 to the 0 power equals 1. All right, moving down below to the next section, it says rewrite the exponential equation in log form. So this time we're going to go from exponential form into log form, which means we're going to need log. And then it's the same process. The base of the exponent becomes the base of the log, so that's 6, and then 36, and that equals 2. Same thing in the next one. We need a log because it's log form. The base of the exponent becomes the base of the log, so that's 4, and then it just kind of goes in this order, 1 over 64, and that equals -3. And so if we were seeing the pattern there, right, I'm using the arrow there so you can see the order that the numbers come in, right, 4, then 1 over 64. All right. Next section is asking you to evaluate these, and so I said that I think the best strategy is to, when it says evaluate, set these equal to x, and then go through this and turn it into exponential form, because it helps you visualize, at least for me, a little bit clearer what I'm looking for here. So that's going to be 5 to the x power equals 25, and then I'm basically trying to say, okay, well, what does that exponent need to be to get me this answer? And that would be 5 to the 2nd power, so this turns into 2. And we go to the next one here. Again, I'm going to set it equal to x. And so it's going to turn into 13 to the x power equals 1. And the exponent that turns things into 1 is actually 0, because anything to the 0 power is 1. And we'll keep going to the next one. 9 to the x power equals 9. So that means the x in this case is going to have to be 1, because 9 to the 1st power is 1. And moving to number 8, same deal. Go through this loop and swoop pattern here. So 4 to the x power equals 1 over 16. And so now we're asking ourselves, okay, well, 4 to what power gives me 16? And hopefully we know that's going to be 4 to the 2nd power. And then we have to ask ourselves, what can we do to exponents to make them fractions? And that's what we can do, is make them negative. So instead of just 4 squared, I'm going to say 4 to the -2. And that actually gives us fractions. So this is going to be -2 for our answer here. All right, so if you got it equal to a fraction, there's a good chance your exponent is negative. And we'll keep going to the next one. This one is particularly tricky, I think. It's going to turn into 9 to the x power equals 3. All right, well, we need to get from a big number 9 to a smaller number 3. And so maybe you remember that if we have a fraction as an exponent, that will take us there. And in this case, the fraction that we're looking for is 1/2, because raising something to the 1/2 power is the same thing as square rooting it. So 9 to the 1/2 power is the same thing as taking the square root of 9, which would give me 3. And then we go to the last one here. That's going to be 3 to the x power equals -27. Okay, so then for this one, if we do 3 to the 3rd, that would give me 27. 3 to the -3rd would give me 1 over 27. But I'm never going to be able to get a negative number here with this exponent. So this is going to be a no solution, because we've got a negative number over there. Okay, so since our base is positive, we're not going to be able to get a negative number over there. All right, next we're going to go to expand these logarithmic expressions. And so for this part, we need to notice that there are 2 terms in the parentheses. So when I expand this, I should end up with 2 log 2's. All right, the first term is a 5. The second term is an x to the third power. And then we need to figure out, okay, what's the symbol that we put in between? Well, hopefully we remember that multiplication turns into addition as we expand. Okay, so multiplication turns into addition when we expand here. So this is going to be a plus sign in between. And then the last thing that we can do is we have this property where we can take these exponents and we can tack them onto the front and be the coefficients of our log there. And so that would be the expanded form, right? And then we can do the same thing below, a little bit more involved because we've got 1, 2, 3 terms here. So we're going to need log 6, and another log 6. 3 of them because we've got 3 terms. The terms are x and y and 7. And now we need to figure out the symbols in between. Well, we have x times y in this original problem, right? X times y. And so remember, multiplication turns into addition, so that's a plus sign. But now we're dividing by 7. And when we divide, when we expand, that turns into subtraction. And so the minus sign there, and that's our expanded form. Moving to 13, we're going to go ahead and condense and simplify. So now we're just going back the other direction. So now we've got subtraction. I want to condense this into just one single log. So I have log base 2, and since it's subtraction, that turns into division. So 28 over 7, those are the properties that we had talked about. And I can reduce that even further. That's going to be log base 2 of 4, right? 28 divided by 7. And then we've got numbers here where I can see if I can evaluate that. Remember, so we set this equal to x, log base 2 of 4, set it equal to x, go through this loop and swoop process, 2 to the x power equals 4, and so then that's going to simplify all the way down to 2, because 2 squared is 4. Okay, moving to number 14 here. Notice we've got some numbers that are in the front of our natural logs here. These work the same way as the log logs, right? So we're going to go ahead and take those numbers from the front and make them the exponents. So I'm going to rewrite this as natural log of x to the 5th plus natural log of 3 plus natural log of z squared. And then since it is addition here, remember addition turns into multiplication for our properties of logs. So I'm going to turn this into one log here, and it's going to be, I'm going to write the 3 first because I can do it in any order here. 3 x to the 5th and z squared. And those would be condensed there. All right, and then we go to the last one here. I'm going to do this in 2 steps to start. So first I'm going to condense these 2 logs. And so that's going to become log to the 5th. And that's 36 over 12, right? Because subtraction becomes division. And so then that's going to turn into log base 5 of 3. Remember, I still have this log base 5 of x. And when I go ahead and condense that, well, that's going to turn into subtraction turns into division. So this is going to be log base 5. Let's see, we're running out of space there. It's going to be log base 5 of 3 over x. All right. These ones will start to solve these equations using logs. So notice when x is in the exponent, it's tough to solve equations unless I use logs. And so we'll go ahead and do that. Remember, we start that by isolating our base of the exponent. So I'm going to start to add 2. And so I get 4 to the x power equals 9. Now I'm going to go ahead and use a log on both sides. So after I isolate the base of the exponent, this is where I would use a log on both sides, and I'll remind you why we want to do this. Because remember, we have that property that allows us to take exponents and move them to the front of our logs. So this is going to end up looking like this. X times log 4 equals log 9. And now I'll go ahead and divide both sides by log 4. And we're going to end up with x equals log 9 over log 4. We can go ahead and evaluate that. I'll pull up the graphing calculator here. That was log 9 divided by log 4. And we get 1.58. Moving to number 17 here, same process. I'm going to start for this one. Notice I'm going to rewrite it just so we have a little more space here. Notice that the base of the exponent is already isolated. We have some stuff in the exponent, but there's nothing down there on the ground level. So I'm ready to go ahead and jump straight into my logs on both sides. Okay, and remember what that allows me to do is take my exponent, in this case it's x minus 5, move it to the front, and I've got log 10 equals log 3. I'm going to go ahead and divide both sides by log 10. Okay, and so those log 10s are going to cancel out on the right side here. All right, and so then I have log 3 divided by log 10, but notice I don't have x by itself, right? I'm still going to have to, at the end of this, add 5 to whatever my answer is here, right? So I can go ahead and rewrite that if I want as x equals log 3 over log 10 plus 5. Okay, and I'll go ahead and punch that into my calculator. I'm going to do it in 2 steps. I'm going to do log 3 divided by log 10. I'm going to get my answer, and then I'm going to add 5 to that. And I get 5.477, so I'll round that up to 5.48. Okay, and keep it going here. Number 18, pretty similar, right? I'm ready to do logs on both sides here because there is nothing down on the base anymore. So I'm going to do log and log. Okay, so then that's going to turn into 2x plus 5 times log 7 equals log 11. Divide both sides by log 7. And so we're going to end up with 2x plus 5 equals, let's see, log 11 divided by log 7. Gives me 1.23. And now I still need to subtract 5. Okay, and then I'm still going to, at the very end, going to have to divide everything by 2. So 1.23 minus 5 and divided by 2. And we end up with negative 1.88. And then we'll move down to natural logs, and these work the same way, except instead of using log, L-O-G, right, we're going to use the natural log, which is ln. So I'm going to rewrite this as e to the x equals 8. And then to cancel out the e, or the exponential, we're going to use ln and ln. And what that does is those things cancel each other out, and it's just going to leave me x equals the natural log of 8. And I can just punch that straight into my calculator. There's a natural log button. Natural log of 8 gives me 2.079, so we'll round that up to 2.08. Same idea here on number 20, except we're going to need to isolate the e first, the base of the exponent, just like before. So I'm going to start by dividing by -6. And I get e to the x equals, that's going to give me +9. Now I'm ready to use the natural log on both sides. So those natural log and e cancel each other out. And I'm just left with the x equals the natural log of 9. Which gives me 2.197, so we'll round that to 2.2. And last one here in 21, start by adding 4. I get 2e to the x equals 20. Now I can still isolate the e by dividing by 2. So I get e to the x equals 10. And now I'm going to use the natural log on both sides. Natural log and exponential cancel out, and I'm left with x equals the natural log of 10, which gives me 2.3. And bingo, bango, bongo, I'm all finished. All right, thanks for watching.